Welcome back to Max with RP. We will continue with word problems in Maxima and Minima. In fact, there are several videos that have been already completed based on word problems in Maxima Minima. Being a very important topic, I would like to exhaust as many type of questions as possible. Now, two sides of a triangle have sides A and B. So you have a triangle whose sides are A and B, and the angle between them you have to find so that the area of the triangle is maximum, and you also have to find what is the maximum area. So let the sides of the triangle be A and B, and let this angle be theta. Then what is the area of the triangle? Area of the triangle, you know, half is half AB sin theta. If theta is the angle between them, we know that it is half AB sin theta. So let me call it as A, capital A equal to half AB sin theta. Now A and B are constants, theta is variable, and we have to find that triangle which has got maximum area. So let us find dA by d theta. This will be half AB cos theta. So what is the critical point? If dA by d theta is 0, then cos theta will be 0, which means theta equal to pi by 2. Okay, which means theta, the critical point is at theta equal to pi by 2. Now what is d square A by d theta square? That will be minus of AB sin theta, because derivative of cos theta is minus sin theta. At theta equal to pi by 2, it is minus AB by 2. Why? Because sin pi by 2 is 1. So, at theta equal to pi by 2, area is maximum. And what is the maximum area? Maximum area is what? Half AB sin theta, which is half AB, theta is pi by 2 into 1, as sin pi by 2 equal to 1. So, two sides of a triangle are given, they are constants, but you can keep on varying theta. So, the question is, what is the, find the angle between them so that the area of the triangle is maximum, and also find what is the maximum area. Area of a triangle is half AB sin theta. We have used the differentiated, found the critical point to be at theta equal to pi by 2. When theta equal to pi by 2, the second derivative is minus AB by 2, and the maximum area is half AB into sin pi by 2, which is 1, AB by 2. Is it clear? Show that the volume of the largest cone that can be inscribed in a sphere of radius capital R is 8 by 27 of the volume of the sphere. So you are inscribing a cone inside a sphere. So let this be the sphere. You are inscribing a cone. The sphere is given, that means what? Capital R is a constant. What is capital R? The radius of the sphere. So this is capital R. Okay. Let me extend this. Let small r be the radius of the cone, and let this distance be x. So capital R is the radius of the sphere. Sphere is fixed. Inside a sphere, you can draw infinitely many cones, but we want to find that cone which has got maximum volume. So let H and R be the dimensions of the cone. So given a sphere, you can inscribe infinitely many cones. We want to find the dimensions of that cone which is going to have maximum volume. Okay. So what is the volume of the cone? Volume of the cone will be, what is the formula? 1 by 3 pi r square h, where r and h are the dimensions of the cone. So both r and h are variables. So you can't have two variables, so we have to express it in terms of a single variable. I know that I can write h as r plus x, and this is also the radius, which is capital R. So small r square is equal to capital R square minus x square. So both r and h now I have expressed in terms of the variable small x, because capital R is a constant. This is a function of two variables. I'm going to express it as a function of a single variable x. How do I do that? I can write h as capital R plus x and r square as capital R square minus x square. So this is 1 by 3 pi. Small r square is capital R square minus x square. H is r plus x. Now dv by dx, to find the critical point, I am differentiating it with respect to small x. dv by dx will be pi by 3 into r square minus x square into derivative of r plus x is 1, because the derivative of x is 1, derivative of r is 0, plus r plus x into derivative of this using product rule is minus 2x. Okay, so this will be, that is dv by dx will give you pi by 3 into, I can take r minus x as common, sorry, r plus x as common, because this is r square, this is nothing but r plus x into r minus x. So if I take out r plus x as common, here I will have r minus x, here I will have minus 2x, so I will be left with r minus 3x. dv by dx equal to 0 implies r equal to minus x or x is equal to r by 3. This is not possible, both are distances. Both r is the radius of the sphere, it cannot be negative. So this option is not possible. The only option is x equal to r by 3. Now, what is d square b by dx square? That will be pi by 3 into r plus x into minus 3, right, plus r minus 3x into derivative of r plus x, which is 1. So this is pi by 3 into, okay, minus 3r minus 3x plus r minus 3x. This is pi by 3 minus 2r minus 6x, which is less than 0. So volume is maximum at x equal to r by 3. If you want, you can substitute x equal to r by 3 and further simplify it and show that it is actually negative. But what is it that you have to prove? The volume of the largest cone is actually 8 by 27, the volume of the sphere. volume of the largest cone is here. I have written here, right? Is pi by 3 r plus x, which is r plus, what is x? R by 3 into r square minus x square. R plus x into r minus, what is the formula? Pi by 3 into r square minus x square into r plus x. R plus x I have written. R square minus x square will be r square minus, what is x square? R square minus r square by 9. This is volume of the cone is pi by 3, 4r by 3 into 8r square. So this will be, take that 8 and 27 outside. Then you will be left with 4 by 3 pi r cube. So this is 8 by 27 volume of the sphere. See, volume of the cone is pi by 3 into r plus r by 3 into r square minus r square by 9. This is 4r by 3. This is 8r square. 9r square minus r square is 8r square by 9. Which is further 8 by 27 into, I have taken this 8, this 3 and this 3 into 9, 27. So what am I left with? 4 by 3 pi r into r square r cube. 4 by 3 pi r cube is nothing but volume of the sphere. So it is 8 by 27 volume of the sphere, which is what we needed to prove. Is it clear? Find the maximum area of an isosceles triangle which is inscribed in the ellipse x square by a square plus y square by b square equal to 1 with its vertex at one end of the major axis. So you have the ellipse, okay, this is A, this is B, x square by a square plus y square by b square equal to 1, okay, in which we are going to inscribe a triangle. What sort of triangle? So you have an ellipse, and you have a triangle. Now it is given that with its vertex at one end of the major axis. So this is the major axis. So this is the triangle. Okay. Now you have to find the maximum area of the isosceles triangle. What is the parametric form for an ellipse? A cos theta, B sin theta. Why? Because when I substitute x square will become a square cos square theta. A square gets cancelled. And I substitute y equal to b square sin square theta, b square gets cancelled, giving you cos square theta plus sin square theta, which is equal to 1. So the parametric form of an ellipse is a cos theta, b sin theta. Now what is the area of the triangle? Area equal to half into base into height. When I say what is this length? See, when you say what is the coordinates of A cos theta by B sin theta. So AB, before I write that, what will be the height? AB will be B sin theta. This total length is A. So what is this point? This point will have coordinates. Suppose I call it as D. What is that coordinate? It will give you what? This horizontal distance, right, is A cos theta. So A minus, what will be the x coordinate of D? A minus A cos theta. So half area will be half into base into height. Base we know is 2b sin theta. This is b sin theta, twice of that, so 2b sin theta. What is this distance CD? CD is a cos theta. So x coordinate will be a minus a cos theta. This distance is what is a cos theta. This whole distance is a. X coordinate of D is a cos theta. So the distance of CD will be a minus a cos theta. So this will be a, I am going to take out AB sin theta into 1 minus cos theta. So this is A. Now dA by d theta will be AB into sin theta into derivative of 1 minus cos theta, 1 minus of minus sin theta, which is sin square theta, plus 1 minus cos theta into derivative of sin theta, which is cos theta. This is further AB sin square theta plus 1 plus cos theta minus cos square theta. This is AB into, I can write that as 1 minus cos square theta. This cos square theta is there, plus cos theta. This will be AB minus 2 cos square. I'll take minus 2AB outside. So minus AB cos square theta plus cos square theta is 2 cos square theta plus cos theta, sorry, minus cos theta minus 1. So this plus 1 I have written as minus into minus 1. This plus cos theta minus into minus cos theta. Minus cos square theta minus cos square theta is minus 2 cos square theta, minus I have taken outside. So this is minus AB into, this is of the form 2x square minus x minus 1. So when you factorize them, what will you get? So when I factorize them, I can write it as 2x square minus 2x plus x minus 1, where x is cos theta. So this will be minus AB into 2x into x minus 1 plus 1 into x minus 1. This is minus AB x minus 1 into 2x plus 1 equal to 0 implies x is 1, that is cos theta equal to 1 or cos theta equal to minus half. If cos theta equal to 1, theta is 0. If cos theta equal to minus 1, theta will be what? Cos 60 is half. So pi minus pi by 3. 2 pi by 3. So what is the value of theta? What is the critical point? There are two possibilities. Either theta is 0 or theta is 2 pi by 3. Okay. We'll continue and check the second derivative. So I'm going to remove this for lack of space. Okay. Now let's look at d square a by d theta square, which will be 2ab into, let's differentiate this. Okay. So if I differentiate, so the first derivative is sin square theta minus cos square theta plus cos theta, which is minus, see first let me write dA by d theta in the simplified form, will give you cos theta minus cos square theta minus sin square theta, which is cos 2 theta. Correct? What is cos 2 theta? Cos square theta minus sin square theta. So this is, I have to differentiate now again. So cos theta, when I differentiate, I will get minus sin theta, right? And when I differentiate cos 2 theta, I will get minus 2 sin 2 theta. Let me try to put theta equal to 2 pi by 3. This will be 2ab. What is minus sin 2 pi by 3? That is minus sin 120, that is pi minus pi by 3. Right? Sin of pi minus pi by 3 is minus sin pi by 3. Sin pi by 3, you know, is root 3 by 2. So, minus root 3 by 2 plus 2 into sin of 2 theta. What is 2 theta? 2 pi by 3. Sin of 2 into 2 pi by 3, which is 4 pi by 3. Sin of 4 pi by 3 is sin 2 pi plus pi by 3. Sin of pi plus pi by 3. Sin of pi plus pi by 3 is minus sin pi by 3. Again it is minus sin pi by 3. So this is minus sin pi by 3. We have already seen is nothing but minus root 3 by 2. So this is 2 into, this one is minus root 3 by 2. This is minus 2 root 3 by 2. Minus root 3. This is minus root 3 by 2. Clearly it is less than 0. Therefore the area is maximum. So I want you to see, I have substituted theta equal to 2 pi by 3 and I directly got it to be negative. Therefore the area is maximum. But then as a student you need to try both the values and check which of these values will give the second derivative, will make the second derivative to be negative. So I hope you found these problems useful. Please practice them on your own. Try them on your own. If you have any difficulty, you can correlate it with the video. But I want you to practice as many problems as possible. So until we meet next time, it's goodbye.